All right, so you saw a little bit about electron configurations and orbital diagrams or notations, but now let's get some notes in your packet. And let's go over a few examples specifically here. Now, the difference between electron configuration and orbital diagrams is that electron configuration is more of a summary. You're going to have coefficients, letters, and little superscripts written up high, whereas orbital diagram or notation, both words can be used interchangeably, is going to be an actual diagram, and there's going to be arrows there. You're going to see what's in the orbitals, and they're obviously electrons, but they're going to be represented with arrows. So the summary is going to have coefficients, letters, and superscripts. The diagram with arrows, orbital diagram, is going to have arrows on small lines which represent the orbitals, and each sublevel is going to be labeled with a coefficient and a letter underneath it or below it. So let's do the electron configuration for magnesium first. Now magnesium is on the periodic table and it's atomic number 12, so it's going to have 12 protons. Therefore, as it's a neutral atom, it's going to have 12 electrons. Now it's not necessarily happy this way. It's going to probably do something to kick out a couple electrons and lose some and become a positive ion, but that's a lesson for another day. Let's just assume it's neutral right now. So we've got 12 electrons. Now picture 12 people coming into the theater. 12 electrons, you're going to try to sit in specific seats. The first 2 people come in and you can sit them in row 1, seat S. 2 people can fit there. If we're doing the orbital diagram, we can actually draw a line representing that seat. Here's row 1, seat S, and we're going to put 2 people in there. And it's always a male and a female, so they're always opposite spins, but no more than 2. Even though there's 12 more people, or 10 more people now, I guess. We already used up 2. Even though there's 10 more people or 10 more electrons that need homes, we're not going to fit any more in here because it only can hold a max of 2. So where do the next set of electrons go? Well, we've got 10 electrons out there looking for a place to hang out. 2 of them can fit in the second energy level, sublevel S. S can only hold 2. So 2 of them are going to sit here. And if we're doing our orbital diagram, we can draw that. 2s. And we can fit 2 electrons there. 1 up, 1 down. 1 male, 1 female. So now we're down to 8. 8 more electrons. 8 more people standing outside the theater. Where should they go? Well, they can't sit in row 1 because it's filled. They can't sit in row 2, seat S, because it's filled. But in row 2, there's the S seats and there's the P seats. So we're going to put some electrons in the P. Now, if you remember, there were 3 different seats, P1, P2, P3, within that subsection. So if you walk down row 2 of the theater, you're going to come across the S's, we've got them filled, and then you come across the P's, and there's 3 options here. And if 2 people can sit in each, and there's 3 of them, we can hold a max of 6. Now we've got 8 people to place, so we're all set. We can fill up the 2P with 6 people. Now watch what I do here. 1 arrow up, 1 arrow up, 1 arrow up. It's only when each of those orbitals in this section, each orbital has an arrow in it or an electron in it, then we can double up. So we go down, down, down. Fill it with 6. So that brings us to 2 electrons. And where do they go? Well, they can't sit in the first row. They can't sit in the second row at all because 2s and 2p are filled. So they're going to have to go to the third row. 3s, and they can both sit there. So I'm going to draw a little orbital. 3s, and they can both fit there. Now, for those of you who might have remembered the 288 business, here's my first energy level, 2. Here's my second energy level. Notice the 2s and the 2p. 2 plus 6 is 8. And then I have just 2, so it's not filled. Remember, it should have 8. It's not filled, so it's going to want to do something about that. And if you look at the orbital diagram, first energy level's got 2. Second energy level, S's and P's together. There's 8. And then there's my last little 2. My whole 3P is empty. I should have another 6 more, but I don't. So that's a problem for magnesium. And we'll talk about how it becomes an ion and fixes this problem. So let's get a couple details straight. Coefficient is always going to be the energy level. Which energy level are you filling? Are you in the 1s? Are you in the 2s? Are you in the 2p? Which energy level are you in? Now that's going to correlate to rows of the theater, or it can correlate to rows on the periodic table, which we'll get into in a future lesson. So rows on the periodic table is going to be equal to the energy level, for the most part. Now the letter this S, S, P, D, F, and so forth, the letter is going to be the sub-level. And remember, sub-levels are types of seats. Are you sitting in the round S seat? Are you sitting in one of the 3 figure 8 P seats? Are you in the clover D seats? Remember, there's one, let me change my color here. There's one S option. It's only round. There's 3 of these. There's going to be 5 of these. And if you throw the F's in there, there's going to be 7 different seats that you could sit in. So where are you? Which sublevel are you in? Now, this doesn't say anything about orbitals. When you do the electron configuration, it doesn't say anything about which particular seat you're in. You just might see P5, and you know all but one of the spots is filled. Or you might see D2, and you know if there's 5 seats and they each hold 2, it should hold 10 people or 10 electrons, but there's only 2 in that sublevel. That superscript tells you the total number of electrons that are currently in the entire sublevel. So how many total electrons are currently in that entire sublevel? Now, it might be filled. It might be S2, it might be P6, it might be D10, or it might be F14. You might have that sublevel entirely filled, or it might be partially filled. Maybe you have S1, or maybe you have P3, or D7, or F13. It's almost filled, but it's missing 1. So it might be partially filled, or it might be entirely filled. But the superscripts will tell you how many are in that entire sublevel. It doesn't tell us anything about orbitals. It just tells us all the electrons in that sublevel. Now, a couple other rules or ideas that you have to understand. Hund's rule. Hund's rule says that you have to have 1 electron in each orbital. Remember, orbital is going to be represented by a line. 1 in each orbital before you double up. 1 in each orbital before you double up. So what we have to keep in mind is that these are electrons. These guys are all negative, and they all repel each other. They don't like to hang out directly on top of each other. So if we have 4 electrons, and we're putting them in the 2p section here, 2p sublevel, there's 3 seats for them. If you have 4 electrons and you only have 3 seats, what we're going to do is we're going to put 1 in each. We're going to let them spread out. And only now we have 1 more electron to stuff in there. Now are we going to double them up? What we're not going to do is force them together and leave an open spot. This is open. These electrons are repelling each other. One of them would love to just jump over here and hang out here instead of being forced to squish together. So this is not right. You want to put 1 in each, and then if you have to, you can double up. Now, Pauli exclusion principle kind of goes along here. Pauli exclusion principle is 2 parts, so know them both. The first part says you can have 2 electrons max per orbital. Now remember, an orbital is really a seat for 2. 2 people can sit in the seat, no matter what it looks like. If it's a P figure 8, if it's a D clover seat, if it's an F weird seat, it can still only hold 2 people. 2 electrons max. B, the second part of this, is in our seating arrangement, we always had a male with a female. In real chemistry, they have to have opposite spins. Remember, they're both negative electrons. They don't necessarily like each other. So one's going to go this way, and the other one's going to try to go opposite to get away from it. So they're always going to have opposite spins, which is why we always have the 2 arrows in opposite directions. So put all of your up arrows first. All these guys go in first, and then you can start doubling up. But when you do double up, make sure it goes the opposite way as your very first arrow.